Hey everybody, today we're going to continue with talking about complex numbers and how to add and subtract them. Now in class, yesterday we talked about what is a complex number and how to change it so that we can't have negatives under the square root. So we have to put this in standard form. Just as a refresher, the standard form of a complex number is a plus bi, where a is the real part and the b is the imaginary, the bi. Okay, so here we have our real part 12 plus the square root of -1. Remember that the square root of -1 is I, so we would simply change this to 12 plus I. Over here we have 4 minus the square root of 25. Notice that the minus is not inside the square root, it's on the outside. So this is simply 4 minus square root of 25 is 5, so that's -1. Okay? So be careful, just because you see a negative doesn't mean you're going to end up with an imaginary number. The negative must appear under the square root for it to be an imaginary number. Alright, so how do we add complex numbers? All we have to do is add the real parts together and add the imaginary parts together. This is combining like terms. So for example, let's say that I wanted to add x plus 3 and 3x plus 4. Remember that when you're adding, you would add like terms. You would add the x terms together to get 4x, and the non-x terms are constants, 3 and 4, to get 7. So the complex numbers are worked the same way, where we have a real part and an imaginary part. You add the reals together and then the imaginaries together. Alright, so let's take a look at this first example. What I'd like to do is, when I combine like terms, is to circle and box things in different colors so I know, and I kind of organize my thoughts, what is added to each other. So I've circled this. This is the real part, and this is the real part. So I'm going to circle both of those in blue. Now 3i and this 3i are both imaginary. And I look at the sign in between the two complex numbers, I'm going to add them. So 2 plus 4 is 6, and positive 3i plus positive 3i is 6i. So adding those two complex numbers has resulted in 6 plus 6i. Alright, doing the same thing here. Here is 1 plus I, and I'm going to add it to 2 plus 9i. So I circle the real parts in green, because that's the color I have on hand, and then plus I and plus 9i. So let's go ahead and add them. 1 plus 2 is 3. I plus 9i is 10i. And the reason it's 10i is because there's an understood 1 in front of this I. So your final answer for this is 3 plus 10i. Alright, so let's continue on. This is the real part of the first complex number. 4 is the real part of the second complex number. I have a -3i and a 7i here. So 2 plus 4 is 6. -3i plus 7i is 4i. Now a lot of you will make the mistake and put 10i here. You have to be careful that whenever you circle and box or color in your like terms, to include the sign that is right in front of it. So this is a -3i. So -3 plus 7 is a positive 4. Alright, why don't you give this one a shot before we move on to subtraction. So pause and give it a shot. Alright, hopefully you have your answer and you are now unpausing to see how you did. So I'm going to circle the real parts in blue and box in the imaginary parts in red. So 1 plus 1 is 2. And positive 2i plus -5i is -3i. And 2 minus 3i is my answer. Alright, so let's move on to subtraction. How do we subtract complex numbers? Before we can do anything, we actually have to change the subtraction to an addition problem. So what we will do is we'll distribute the negative to the second complex number and then add them like we have just learned how to do. So taking a look at this problem, I'm going to distribute the negative to both parts of the complex number, both to the real part and to the imaginary part. So when I do that, this becomes a negative 2 minus I, because the negative changes the positive 2 to a negative 2, and the negative changes the positive I to a negative I. Now I'm going to bring down the first complex number because I didn't do anything to it. Once I've distributed the negative, this becomes an addition problem. So we can add just like we have done in the previous problems. I have 4 plus negative 2 gives me 2. And then a positive 3i plus a negative 1i should be a plus 2i. And there you go. You have accurately subtracted those two complex numbers. Alright, so let's do another example together. Let's first distribute the negative to both the real 7 and the imaginary 2i. So this becomes a negative 7 minus 2i, bringing down the first complex number because we did not change it, and since we distributed the negative, it becomes an addition problem. So 3 plus negative 7 is negative 4, and 6i plus a negative 2i is a positive 4i. So that right there, negative 4 plus 4i is my answer. Alright, here's what I'd like for you to do. Now that we've done two examples, if you would, go ahead and pause and subtract these two complex numbers. When you are done, unpause the video and see how you did. Alright, hopefully you have just unpaused the video, you have your answer, and you want to know, did I do this right? So first step would be to distribute the negative to both the 3 and the 6i. So it becomes negative 3 minus 6i. You bring down the first complex number because we did not do anything to it to change it. Since the negative has been distributed, we now make this an addition problem. So adding like terms, 5 plus negative 3 is 2, and 6i plus a negative 6i is a 0i. So you can either leave it like this, or you can simply say 2 is your answer. So notice when I subtracted these two numbers, I actually resulted in a real number, not a complex number, a real one. Alright, let's try another example. Distributing the negative in. 2 plus 16i remains the same. It becomes addition. So negative 2 minus 3i when I distribute the negative in. So let's add 2 plus negative 2 is, well, 0. And 16i plus a negative 3i will be a 13i. So you can either leave it like this or simply put 13i. Alright, now with this one I want you to be careful because what happens when I distribute a negative to a negative? Two negatives make a positive, so negative times negative 2 is a plus 2, and negative times a positive 3i is a negative 3i. So that's what makes this problem just a little bit different than the previous problems, is that the negative changes the sign. If there was a negative, it becomes a positive. If there was a positive, it becomes a negative. So now that we have this correctly, we can go ahead and combine our like terms. 2 plus 2 is 4. And this is I plus negative 3i. So that would be negative 2i. And that is our final answer. Alright, that's it for adding and subtracting complex numbers. Pretty short and sweet today, and we'll talk about multiplying these complex numbers tomorrow. See you later.